In the last episode, we discovered that most of the matter in the universe is invisible. Dark matter, something we cannot see, but whose gravity we can measure. Dark matter showed us that there was more gravity in the universe than we could account for, more mass, and therefore more gravitational pull than anyone expected, which only strengthened a very simple expectation. If gravity dominates the universe, then the expansion of the universe should slow down, or at the very least, remain steady. But there was no reason to expect it to speed up. To answer that question, astronomers needed a way to measure distance across the universe. But measuring distance on the scale of the whole visible universe is not simple. To measure distance across the universe, astronomers needed something they could rely on, something visible across vast distances. What they needed was a standard candle, an object whose true brightness is known. And for that, they turned to a very particular kind of system. In a binary system, a white dwarf and a normal star orbit each other. As it turns out, systems like this are not uncommon. As the companion star evolves and expands, material begins to flow onto the white dwarf. But there is a hard upper limit to how much mass a white dwarf can hold. That limit is about 1.4 times the mass of our sun. Cross that limit, and the star becomes unstable. It detonates as a type 1a supernova. A single explosion can briefly outshine the entire galaxy in which it resides. And because every one of these explosions occurs at nearly the same mass, they all reach approximately the same intrinsic brightness. If one of these supernovae appears dim, it isn't weaker, it's farther away. In the 1990s, two independent teams set out to measure how the expansion of the universe was changing over time. They used those observations to measure the brightness of distant type 1a supernovae. The supernovae were dimmer than they had any right to be. These scientists led two independent teams that were studying distant type 1a supernovae. The expansion of the universe was not slowing down, it was accelerating. This was completely unexpected. Something was pushing the universe apart. We now call this something dark energy. And to this day, we do not yet understand what this something is. In the span of a few decades, our understanding of the universe changed in fundamental ways. What we once thought was slowing down is now known to be speeding up. And whatever is driving that acceleration makes up most of the universe itself. It is a reminder that even now the cosmos still holds more mystery than certainty. And that, perhaps, is what makes the journey worth taking. So, come walk with me.